Okay, so now I'm going to talk about Lagoa Mesh Advection. Now, Mesh Advection is basically the process of having some kind of a Lagoa particle emission interact with our cloth mesh over here. So basically we can shoot particles at it and have the particles hit the cloth mesh and have the cloth mesh deform and react to these particles that are hitting it. Think of, hanging a blanket or something on a tree or something like that, and then throwing baseballs at it or something like that. When the baseball hits the cloth is going to react and bend and deform and stuff like that. So that's something we can do here with Lagoa. Now, the setup is not as easy as the stuff we've seen so far. There's a little bit of a manual setup process that we have to do. It's not going to be completely automated like we've seen most of the different processes with ice are automated, but this process is not automated. You have to know exactly what nodes to plug in where and how. Okay, but I'm going to show you that now, so it's no big deal once you understand. But I'll go nice and slow so that it makes sense. Another thing that I want to note here is that while I was working with this scene off camera, and I was actually trying to record this video several times, I had SoftyModge crash all the time. And I figured it out. I found out why. I guess it's a bug. Definitely SoftyModge is not supposed to crash at all. That's not the idea. But I found out why it was crashing. And when I get to that point, I'm going to show you how to stop it from crashing. Hopefully it doesn't happen to you. But it happened to me every single time. So I'll show you that when I get to it. Alright. So pretty simple stuff. I'm going to take the cloth here. And if I check out the cloth, you notice that under the modeling construction stack, I have some construction history. If I continue forward the way it is right now, I'm going to run into some problems, and I don't want to do that. So with the cloth selected, I'm going to freeze modeling. And now if I look at the selection, all I have is my ice tree. All that other junk is now gone. Okay, the ice tree is protected, by the way, because it's under the simulation construction stack. Alright. So with the mesh selected, I'm going to go over here to the Create Particles menu. And down here in the Lagoa Particles, you've seen me use volume emission quite a bit, and I've largely ignored Mesh Advection. Now we're going to use Mesh Advection. So go ahead and click on that. And SoftyModge is going to ask you to select colliders. So I'm going to select the colliders group over here in the Explorer. And SoftyModge right now is going to hook up everything for me automatically. So basically two things are going to happen right now. One, SoftyModge is going to create a new particle cloud, and two, the particle cloud is going to have a totally new ice tree created. So we can see down here, we can see in the Explorer, there's a new Advect Mesh point cloud that was created. It's a point cloud just like any other point cloud that we've seen so far, and down here you can see its ice tree. It has this Lagoa Setup Advect Mesh compound. If we open up the PPG, it's pretty simple and straightforward. But what I want to do is I want to do things manually because that's how I like to do things. So I'm going to select this compound. I'm going to go to the Compounds menu and explode it. And you can see it's a pretty standard ice tree. If I have a look at this, you can see that I have the cloth over here in this Get Data node. And then this new node was created, a pass-through node, which is going to pass data over from the cloth. And it's going to be split in two ways. Data is going to go over here to the emitter. This is the Lagoa Emit Mesh node, okay? We've seen the Emit Grid node and a couple of others, but the Emit Mesh node over here is specific to this. Down here we can see that we have a wire that connects to this new node that we haven't seen so far. This is the Lagoa Advect Simulated Mesh node down here, and it actually plugs in after the Simulate Multiphysics node, alright? Pretty important. Okay, we also get a material cloth compound over here. It's created automatically. And, of course, our Lagoa Transform Constraint compound over here. Now, very important, this ice tree isn't the same one that we've worked with before. If I select the cloth object and I refresh the ice tree down here, this is the original ice tree. It's still there. This is for the cloth. But we have a new ice tree that's applied to this, and this is for the Mesh Advection. Okay? So the way that this works is pretty simple. What we're going to do is we're going to use this to create some particles. We're going to shoot the particles to the cloth, and we're going to have the cloth react to those particles. Alright? And to do that, it's a little bit of a process, but let me show you how to do that. Now, we're getting close to that bug that I mentioned a couple of minutes ago, where SoftyModge just kept crashing for me over and over and over again and wouldn't stop. And I figured out what it was. apparently some kind of little bug here, but there's a way around it. Okay, what happens is if I hit play right now, you'll notice everything looks normal, and then suddenly we start to get all these little yellow lines that are shooting all over the place. It's kind of an abnormal thing that actually shouldn't be happening. If I continue to play this, I actually stop the simulation right now so that it wouldn't crash. If I continue to play this, when it gets to around frame 100, it'll crash every single time, at least for me. I don't know, maybe it doesn't happen to you, but if it does, the way around that is I found that if we go back to the original ice tree for the cloth, this one right here, if I go to the multi-physics node here and I take the substeps and drop it down to 2, now suddenly we don't get those little yellow lines flying all over the place. Everything looks nice and normal now. Okay? And we can continue to play this in the timeline and it won't crash. At least for me, it's not crashing anymore. So it's kind of a weird quirk. No software out there is perfect. They all have their little bugs. Hopefully they'll fix this one. The cloth right now is falling down, so I want it to be constrained. So I'm going to go over here and select the Advect Mesh ice tree over here. And what I'm going to do is I'm going to grab my constraints group, drop it in here. I'm going to plug it into the transform constraint compound. So now when I play this back, the Advect Mesh point cloud, everything stays intact the way I would expect. Now here comes the really important part. What I'm going to do is I'm going to create a new null, which is going to be my particle emitter. And I'm going to take it and I'm going to place it over here somewhere, just kind of in front of the cloth over here. And I'm going to change some settings. I'm going to call it emitter. I'm going to switch it over to rings. That's what I like to use for this. And the size, maybe I'll make it about a size of 3. Yeah, that looks like it'll work out just fine. Now, what I'm going to do is I'm going to take this emitter and I'm going to drag and drop it into my ice tree. You want to make sure that you're using the Advect Mesh point clouds ice tree. Okay. We're going to need a few more nodes. There's a little bit of a manual setup to this. Okay. Let's go over here to our preset manager under Lagoa. And let's grab ourselves, actually, I'll just do a search over here real quick. I'm going to get myself an execute node first of all. So I'm going to start to type in the word and drop in an execute node. And I'm also going to need, let me clear that out. If I go to element creation under Lagoa, you'll find all the Lagoa element creation nodes here. What I want to do is I want to grab the emit grid, drag and drop it over here. Okay, it's going to be red at the moment, but don't worry about that. It's no big deal. We're still not done dropping in some special nodes over here, but I'll get to the other ones when I get to them. Let me also maximize this view. Okay, so let me move this up and just organize this a little bit better. What I'm going to do is take the emit mesh node over here and plug it into the first port of the execute node. And then I'm going to take the emit grid and plug this into a new port 2. So I'll make a new port, which is going to be automatically port 2. Then I'm going to take the emitter and I'm going to plug this one into the new emit grid node. Still going to have a little bit of problems. It's going to be red right there, but that's no big deal. Then what I'm going to do is I'm going to take this execute node and I'm going to replace the emitter plug. I'm going to plug this in there. So just give it a second here. So plug that into the emitter port of the simulation root, and now this thing's no longer red and it's working. So basically the way this works is the emit mesh connects to the execute. Same thing with the emit grid, that connects there, and then the execute is going to pipe all that data over to the emitter port over here in the simulation root compound. Now the way this works is whenever you have multiple emitters inside of one of these Lagoa ice trees, you have to have, each one has to have its own phase node and each one has to have its own material node. So that's really important. Right now we only have one Lagoa phase node, so we're going to have to create a new one. And an easy way of doing that is I'm just going to hit Control C and Control V to copy the Lagoa phase node. Just a faster way of getting that done. And I'm going to take this one and I'm going to plug it into this new execute 1 port over here. So basically we're going to create a new execute port in the simulation root. So execute 1 is for this first phase and execute 2 is for this new second phase that we've just created. We're also going to need another material. Now the material can be anything you want. In this case, just for the sake of doing some interesting stuff, what I'm going to do is I'm going to get myself just maybe I'll get myself just a generic or a liquid water. Let's get a liquid water over here. Let me kind of minimize that there. It's really good to take these ice trees and kind of organize them a little bit better, just so visually. So I'm going to plug this into the execute one right there, the material. We don't need a transform constraint for this, so don't worry about that. So we've got ourselves our liquid water material right there. Okay, we're still not done. There's still a little bit more editing we need to do. Very important when you're working with multiple phases, and we'll see this later. I'm going to go more in depth on this. We need to give each one of these phases a specific ID number. So I'm going to go to this emit mesh over here, and this one you can see down here under the simulator settings. There's a phase number, and you can change the phase number here. I'm going to leave it at phase 0. So the ID for this mesh, this emit mesh node, is going to be phase 0. So I'm going to go down to its phase right here. This is its phase. If I open it up, there's a phase ID which right now is 0. So that's perfect. Now the emit grid node over here is using the same phase. We're going to get a problem if we do that. So I'm going to switch it over to phase 1. I'm going to go down to the new phase that I plugged in, and I'm going to tell this one to be a phase ID of 1 as well. So that'll make sure that the two emitters are separate and they have their own phase IDs. And again, I'll talk more about that later on in another video where I'm going to dive specifically into multi-phase systems. But right now, let's just do this. Okay, the other thing I want to do is if I go to Lagoa Add Forces, I have a ton of density, so I'm going to turn off that density. And as usual, I'm going to come over here to my Lagoa Forces, grab myself one of these air density nodes, which I prefer to use. And I'm going to plug it into the Force 1 node, or Force 1 port. Alright, so I think we should be all done. I may have forgotten something, but if I did, I'll just go back and fix it. Alright, oh yeah, I did forget something important. I want this thing to shoot out particles toward the cloth, so if I look at this, I'm going to have to shoot out in the negative Z to get it to go straight to that cloth. So what I'll do is I'll go to its emit grid, and I'm going to give it an initial force. And let's fire it about negative 20 in the Z. I'm also going to decrease this resolution. We don't need that much. I'm going to set it to about 0.5. I'm also going to set it to emit at every frame, so it's constantly shooting particles at the cloth. And let me go with hex placement over here. All this other stuff looks good. Multi-physics. Right now the substeps is set to 1, which is pretty low, but let's go ahead and let's see what we get. I just saved right now, in case you didn't catch that. I just saved. So we're going to shoot this out, and whoa, the resolution's still too tight. Let me go back. Let me actually set that to 1. Rewind, play again. Okay, that's much better. The particles are not shooting out with enough force. You can see they're not going to reach the cloth, so I'm going to have to use more initial force. So let me go up negative 100. Rewind and play again. There we go. Now those particles are really shooting out. Let me actually reduce that. That's a little crazy. So let me go about negative 50. Particles are going to shoot out. They're going to hit the cloth. Cloth is going a little bit haywire on me. So let me go down to the multi-physics, and I'm going to increase the substeps to about, I think 2 will work out fine. Rewind, let me play this again. That's a lot better. It's still acting kind of funky. To fix that, you would have to continue to increase the substeps. I don't think I want to do that though, just so that everything doesn't slow down to a crawl. So let me maybe increase the subframe sampling to 2, see if that helps. And that actually made everything go really, really slow. So let me go ahead and set that back to 1. I'm just going to keep it the way it is. I think it serves its purpose of kind of illustrating how this works. Notice that the particles hit the cloth. They're going to go through the cloth, but when they hit the cloth is going to react. It's going to react and deform based on the particles that are hitting it. So let me go to the liquid water over here and reduce some of these settings right here. Also, another thing that's important is I don't have the enable pressure turned on. In the multi-physics node, I want to make sure that enable pressure is actually turned on, because I'm actually, trying to calculate the pressure. Okay, so looks good. Let me close that. Let me also go to Orient Particles and turn that off. So let's shoot the particles again. They're kind of spreading out more now. They're going to hit the cloth, and the cloth is going to start to react to those particles. And again, if it's acting kind of jittery and quirky and stuff, you'll have to do a couple of things. You have to go to the cloth material over here and adjust some of the elasticity settings and stuff. You'll also have to go to the multi-physics node and increase the substeps. Right now we're using only 2. If I go to 3, it's going to be more accurate, but things are really going to start to slow down. But I think you get the idea of how this works. So you can take a cloth mesh and have particles hit the cloth mesh, and the cloth mesh is going to, as you can see, deform and react to those particles that are hitting it and going through it. So it's a pretty neat sort of way here to create some interesting simulations, if you like. So you can see how the particles are hitting the cloth mesh there, and the cloth mesh is just kind of flying all over the place right now. So it's a pretty cool way of creating some Lagoa simulations. So that's mesh advection, and it's pretty heavy on the simulation side, so you want to make sure if you do this, have a good piece of hardware to get this done with, and expect the simulation to slow down, because we're doing multiple simulations now. Now we're doing cloth, we're doing the cloth mesh advection, and we're doing these particles that are shooting out from this emitter. So essentially we're doing 3 different simulations that are working together at the same time to achieve this effect. So obviously that much simulation is going to take a toll on performance, but it's no big deal. Softimage handles it pretty good, and when you render it out and you start caching, use the cache tools that I've shown you before, you can cache this stuff out and get yourself some really cool stuff going at a decent pace. Okay, so that's going to do it for mesh advection. Don't really think there's anything more for me to cover here. So there's cloth, mesh advection, working with constraints and stuff like that. So that's going to do it for this. I'm going to end this video here, and in the next set of videos we're going to start a new sample project. It's going to be a little bit more advanced, and I'm going to be moving a little bit quicker and covering some more advanced things.